Now, let's look at the uses of electrolysis. The first use we have here is purification of metal. Okay, so during electrolysis, the ores of the metal or the impurity, that thing that is making the metal impure, you know, I already explained impurity to you when you say a substance is impure. When we treated substance, okay, types of substance, impure and pure substance. Okay, when you have anything that is not of that element in that element, it becomes impure. For example, sodium is pure, but when you have oxygen in it, sodium oxide, it becomes impure. It is no longer sodium metal again. It's now impure. So the ores, especially ore, oxygen, the ore, when oxygen joins with metal or when oxygen combines with metal, it is called ore. The resulting compound is called ore. When oxygen combines with metal, the resulting compound is called ore. Okay, so that ore is impure. Okay, it's impure. So when you add anything to a substance, it becomes impure because it's no longer solely that substance. Okay, so how do we separate whatever is making copper impure? Most of the time is oxygen, ore. Okay, their ore. How do we separate it, copper from their ore? You use electrolysis, and it's not only copper. Okay, you use electrolysis for elements. You use electrolysis to extract elements higher up the activity series. Then the ones lower up the activity series, you use roasting of ores. I also give you expo for inside elements and their compound. We big for inside chemistry textbook like this. I'm giving you all the expo, what you need to know. So impure copper, now will be the anode. That one with the bomb. The one where they dissolve, then go be the anode. Then pure copper will come be the cathode. Impurities fall as anode mode. Okay, so when it dissolves, that's impure copper side. When the anode dissolves, it will come from anode mode. No anode again. Now mode will come there as impurity. The second use of electrolysis is production of elements. For example, aluminium is produced from aluminium 3 oxide, which is what? Cryolites. Okay, sodium is produced from fused sodium chloride. Okay, oxygen is produced from water. Okay. Chlorine is produced from what? Sodium chloride. That's electrolysis of brine. It's also used in the production of elements. When you want to separate one element from the other, okay, you want to separate one element from the other. You know they are compounds. So separating one from the other, you are going to need electrolysis. Okay, so you use electrolysis to manufacture elements. The third here is production of compounds such as sodium hydroxide. Okay, production of compounds such as sodium hydroxide from concentrated sodium chloride via chloralkali process. So the chloralkali process is used to produce what? Caustic soda from sodium chloride. Okay, where sodium chloride, 2 moles of sodium chloride reacts with 2 moles of water to form what? 2 moles of what? Sodium hydroxide, chlorine, and what? Hydrogen gas. So that include electroplating. You know what electroplating is now? Coating metal with another metal to prevent corrosion or to enhance luxury. Okay, to make the metal look more lustrous. Okay, look more sparkling. To enhance that sparkle look of the metal, to enhance cosmetics and aesthetics. Okay, it's also used in the extraction of reactive metal. Like I said, metals higher up the activity series, which are reactive, very reactive. You use what? Electrolysis. While the ones lower, lower the activity series, all those metals will not to be reactive. You use roasting of their ore under the earth. Now let's look at the electrochemical series. Electrochemical series where the talk is. This is the electrochemical series I have been talking about. Okay, just take this order as first, second, third, fourth, fifth, sixth, 7, 8, 9, 10, 11, 12, 13, 14. So write out like this for your notes from up to down. From up to down. Okay, this potassium will be the first, while the last will be what? This one, gold. Gold will be the last. Okay, potassium first, gold last. So that one are the ranking. Okay, ranking. Potassium na the what? Number 1. Now be the most reactive. So by reactivity, now potassium be number 1 for electrochemical series. Okay, potassium now be number 1. So that's it. Then the last one will come be waiting gold. Okay, so gold now be the what? The least reactive for the electrochemical series. So put this electrochemical series for your head. It's too easy. Potassium, calcium, sodium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, and gold. Significance. What is the significance of electrochemical series? Why is it important to us? Why is it important? Make we know them. Wetin we dey use and do? It helps us to predict displacement reactions. Yes, that's the number 1. What is displacement reaction? Displacement reaction is a reaction whereby when 2 salts they react, or 1 salt and acid they react, which go displace which go take which position. This electrochemical series they determine metal go take the position of unreactive metal. So if you have a chemical compound with potassium that is reacting with another chemical compound with iron, one is going to displace the other and take the other's place. What determines this displacement is its position in this electrochemical series. The one that is higher will displace the one that is lower. So potassium will displace iron. in their salt or in a solution of their salt. Calcium will displace magnesium in a solution of their salt. Sodium will displace magnesium in a solution of their salt. Aluminium will displace zinc in a solution of their salt. So zinc can't displace aluminium. Zinc can't displace magnesium. Zinc can't displace potassium. So that's so it be. So that's one of the significance of this electrochemical series. Okay. The second significance is electrolytic products. During electrolysis, the products formed, like I said before, the elements that discharged first during the electrolysis are the ones down the electrochemical series. The ones that takes later, that discharge later, okay, are the ones that the most reactive ones. That's the ones up the electrochemical series. And it's also significant in cell potential, and that cell potential is what we are going to treat right away. So cell potential is the capacity of a cell. So the capacity of a cell is dependent on the constituent of the compound that makes up the cell. If the cell was built with elements like potassium, calcium, sodium, all these reactive ones, the cell will get high potential. The cell is going to have a high potential. But if the cell was built with copper, mercury, the cell potential will be low. All right. Now let's look at electrochemical cells. Electrochemical what? Cells. Okay. Before we looked at this electrochemical cell, I just quickly brushed through this electrochemical series. Electrochemical cell is a device that converts chemical energy to electrical energy. Okay. They are known as battery cells. Okay. Let's now look at half cell reaction and electrode potential as recommended by Jamb. This is the standard reduction potential, which is E naught. E what? E naught. Standard reduction potential. For example, zinc gains 2 electrons to form zinc metal. And this is what? This is a reduction process. Okay. And what? The standard reduction potential, which is E naught, is equal to minus 0.76 volts. So you need minus 0.76 volts for this oxidation to occur in an electrochemical system. Okay, you need this one, the standard reduction potential. Okay, so this is a half cell reduction process. You can see that this one is having negative. Okay, negative 0.76. It's a half cell reduction process. Another one here is copper gains 2 electrons to form copper metal. Okay, then the standard reduction potential is equal to plus 0.34 volts. Now I am going to show you how to use this standard reduction potential to arrive at answers. All right. Cell potential. Cell potential, which is cell E, is equal to cathode minus anode for spontaneous reaction. A reaction that occurs naturally. You use what? Cathode minus anode. You minus what you have on the anode from what you have on the cathode to get what? Cell potential. It's very easy. You minus what you have on the anode from what you have on the cathode to get what? Cell potential. The formula is very easy. Cathode minus anode. Remember, we are now in electrochemical cell. Remember what I told you in the beginning of when we were treating electrolysis. I told you something that cathode and anode, what they represent, they are electrodes, but what they represent in electrochemical cells, what they represent in electrochemical cells is different, is opposite of what they represent in electrolysis. So in electrolysis, cathode is negatively charged electrode or negative electrode, but here it's now positive. In electrolysis, anode is positively charged electrode, but here it's now what? Negative. So there is opposition. Okay, it changes, it interchanges when you enter electrochemical cells. Simple calculations under electrochemical cell. For example, this is how they are going to bring the question. They are going to show you a cell like this. This thing you have here shows you that this is a battery. Okay, this is a bridge. Okay, usually salt bridge. These two bold this thing you have here, salt bridge. This double is salt bridge. Then this one, this kind of equation is a battery equation. Okay, where you have this pipe. Okay, double pipe in the middle to separate. This is a salt bridge. That's what this is called. All right. So for example, this calculation here, the cell potential is equal to 0.34 minus bracket open minus 0.76 equal to 1.10 volts. Remember the formula of cell potential. Okay, cathode minus anode. All right, cathode minus anode. That's the formula. And remember how to use sign in math. So you can see that this one that is having minus, they put on for brackets because you are going to do minus times minus here to get your answer. To get plus, then you add and you get your answer. But if you can't go command this minus now, can't use only minus, you are going to get the wrong answer. So you have to follow mathematical rules here. So here, copper is the cathode, zinc this side is the anode. So it was solved here, cathode minus anode. Okay, it was given. Okay, the value for cathode, which is copper, and the value for anode, which is zinc, was given. Look at it here. Look at the value here. This is the value of the anode, which is zinc. Okay, minus 0.76. Okay, while that of the cathode, which is copper, is plus 0.34. We apply this formula for cell potential, which is cathode minus anode, to get the answer here. All right. 1.10 volts. Now let's move over to types of cells. Okay, the first type of cell we have here is galvanic cell, which is what? The spontaneous cell. They are also known as the primary cells, such as simple cell. You know them now, Daniel cell, the Clancy cell, and so on and so forth. We have electrolytic cell, which is non-spontaneous. Okay, non-spontaneous cell means that the reaction doesn't occur on its own. Okay, the cellular reaction doesn't occur on its own. It is induced. It's non-spontaneous. Okay, you can see what is written here. It requires external volts. Okay, it requires what? External voltage to function. These kinds of cell requires what? External voltage. You have to induce it before the cell starts working. But for all these spontaneous cells, as Daniel cell, Leclanche cell, lead accumulator, lead acid cell, zinc cell, and so on and so forth, all those cells, they are all spontaneous cell. Okay, they are all spontaneous cell. You don't need to, induce them for them to start working. All you need to do is you charge. When the cell has discharged all its ion, you charge. Okay, and when you are charging the cell, you are forcing ions to shift from one electrode to the other. If all the ions has been pushed or transferred to the negatively charged electrode during charging, as a result of charging, when you are charging the battery, all the ions moves back to the what? The positively charged electrode. That's when you are now going to say, yes, my battery don't full, it don't charge, because there are ions in the positively charged electrode to be discharged, okay, to be discharged for consumption, okay, for your electricity consumption, okay. So while you are using the battery, as you make use of the battery, ions are discharged. Ions move from what? They move from the positive electrode to the negative electrode. It's continuous until all the ions have been what? Discharged. At that time the battery will flat, don't run down. But when you start charging it, the ions move back to what? The positively charged electrode, so that it can be discharged, because ions can be discharged from negative charged electrode. Corrosion and prevention. Corrosion as electrolytic process. That's, we are looking at ion rusting, or rusting of ion as an electrolytic process. So rusting of ion is a chemical process, it's a chemical change, and it's also an electrolytic process. Now let's look at what happens during ion rusting. Ion, which is iron metal, rusts and form what? Ion. What kind of ion is formed? Ferrous ion. Okay, ferrous ion is formed, which is iron 2 oxide. Iron 2 ion is formed at the anode. So iron 2 ion or iron 2 oxide makes the what? The anode. Iron 2 ion or iron 2 oxide forms the anode. Okay, and in the anode, what happens in the anode during electrolysis? Oxidation occurs, and what happens there? Oxygen combines with water, and 4 electrons are lost. Okay, and hydroxide is formed. Okay, at this what? At this anode. This is the oxidation process that occurs here. Okay, so hydroxide is formed because oxygen is added to water, or oxygen combines with water to form hydroxide. Because from the start of the oxidation, ion loses 2 electrons to form what? Iron 2 ion. And when it forms this iron 2 ion, it combines with water and oxygen further, and more oxidation occurs because 4 electrons are lost, okay, to form hydroxide. And the hydroxide form is what? Iron 2 hydroxide. And this iron 2 hydroxide form forms the what? Cathode. Okay, as it forms the cathode, it gets oxidized further to form iron 2 oxide. So what is the prevention of rust? Rusting of iron. How do we prevent rusting of iron? The first preventive method here is cathodic protection. Okay, this place that forms the cathode, we are going to find something to put there as a barrier to prevent this iron 2 hydroxide from forming. So what is that? That's what cathodic protection implies. So we attach more reactive metals such as magnesium to iron. You attach magnesium to iron. Magnesium corrodes instead of the iron. So instead of iron to be corroding to be forming iron hydroxide, magnesium will now be corroding and be forming magnesium hydroxide. All right. So another method of preventing iron rusting is painting the iron. Painting can serve as a barrier. That's why if something they rust, they will carry paint, they paint them to serve as a barrier. That's why they paint gas cylinder, okay, to prevent corrosion, or to limit corrosion, or to limit the possibility of corrosion. All right. So the next we have here is electroplating. Okay, and electroplating involves coating with less reactive metal. Okay, the one you do with electrolysis. So you are going to use a less reactive metal to coat the exterior of the iron to prevent corrosion, to act as that barrier so that that cathode no go form. Remember, rusting of iron is an electrolytic process. So you paint it. When you paint it, you have broken that pathway. Okay, you have broken that pathway that facilitates the occurrence of electrolysis, which is the rusting of iron. So you use elements like zinc or copper to coat the iron to prevent corrosion, and this is usually done with electrolysis, okay, electroplating. There is also another one. When you use zinc to coat iron, it is called galvanizing. When you use zinc to coat iron, it's called galvanizing. So galvanization, write down in your note, galvanization is the process whereby zinc is used to coat iron to prevent corrosion. All right. The final method of preventing iron rusting here is coating with grease or oil. So if painting can serve as a preventing measure, why can't oil or grease serve as a preventing measure? If you coat it with grease and oil, remember, for iron to rust, you need oxygen and you need water. So if oxygen and water can't come in contact with that iron metal, rusting will not occur because oxidation will not occur in the anode. Okay, so you need oxygen and water for iron to rust. So when you coat it with grease or oil, you prevent oxidation from occurring at the anode. When you electroplate the metal, you prevent water from coming in contact, and you prevent what? Oxidation from occurring in the what? The anode. Painting, which is also barrier against motion. When you paint, you break that pathway. You prevent oxidation, this oxidation here, from occurring as the anode. That's it. So the goal of preventing ion corrosion is to prevent the oxidation, to break that pathway of oxidation in the anode. So my takeaway for all Jamb bites in this lecture. The first here is memorize the electrochemical series and common electrolysis products, such as the one we just discussed. But I already told you how to smartly detect the elements that is going to be discharged during electrolytic process, provided you are told the electrolysis, the electrolyte that was used. You should be able to select among the option the products that was given off during such electrolysis. But it's good to learn them so that they will not deceive you with 2 non-metals and 2 metals, okay? Because Jamb can just bring 2 non-metals. If you don't know before, you might go and pick the non-metal that is not, but it's usually part of the electrolyte. So you are going to pick the element that is part of the electrolyte, because an element that is not part of the electrolyte will not be discharged during the electrolysis of that electrolyte. So you have to pick from the elements that makes up that electrolyte using the method, the like charge repair or like charge attract, using the cathode and anode charges and the charge on the elements as a guide. The second takeaway here is practice balancing half reaction and calculating masses using Faraday law. This calculation of masses using Faraday law, we are going to treat this one. We will start treating calculation in 2 weeks. Okay, in 2 weeks time we'll start treating calculation. I'm going to teach you how to use this one. Already I have taught you how to use it in this video, but I'm talking about practicalizing it. Seeing me when I'm solving it and learning it like that, because I just told you how to substitute, how to solve. If you go and start practicing now, you are definitely going to master this thing. So that's why you have to start practicing now, even before I start treating calculations. And remember, the calculations I'm going to be treating are the high heats. I'm not going to treat any calculation other than the high heats. All right. The third takeaway is draw diagrams for setup and cells. Learn how to draw diagram for setups and cells. Cell diagram. Learn it. It's very easy. This balancing of half reaction, I already treated this in this lecture, okay, when we treated cell potential and so on and so forth. Hope you still remember the formula for cell potential. Do you? You thought right. The formula is cell potential is equal to cathode minus anode. Now that we have understood the concept of electrolysis and the concept of electrochemical series and electrochemical cells, let's now take some Jamb must repeat questions to further test the knowledge we've acquired so far. Let's know our strengths and our weaknesses so we can go back to revise what we have learned. Jamb must repeat questions. Question 124. Which of the following is a non-electrolyte? A. Sodium chloride solution. B. Hydrochloric acid. C. Sugar solution. D. Sodium hydroxide solution. What's the answer? Drop the answer in the comment section. Question 125. During the electrolysis of dilute sulfuric acid and using platinum electrode, the gas liberated at the anode is what? A. Hydrogen. B. Oxygen. C. Chlorine. D. Sulfur dioxide. What's the answer? Drop the answer in the comment section. Question 126. The electrochemical equivalence of a mass is 0.00033 grams per watt per coulomb. If a current of 0.5 ampere is passed through its solution for 30 minutes, the mass of the metal deposited is what? Take 1 Faraday equal to 96,500 coulomb per mole. A. 0.099 gram. B. 0.198 gram. C. 0.297 gram. D. 0.396 gram. What's the answer? Drop the answer in the comment section. This question is just so cheap. Use the what? You know the law to use now. Here is the law of Faraday, but you are the one to know if it's the first law or the second law that you have to use to solve that question. Question 27. In the electrolysis of aqueous copper 2 chloride using inert electrodes, the products at the cathode and the anode respectively are A. Copper and chlorine. B. Hydrogen and oxygen. C. Copper and oxygen. D. Hydrogen and chlorine. What's the answer? Drop the answer in the comment section. Question 128. The significance of the electrochemical series is that it helps to what? A. Determine the rate of reaction. B. Predict the product of electrolysis. C. Calculate the atomic mass of elements. D. Identify non-metals. What's the answer? Drop the answer in the comment section. Question 129. In a Daniell cell, the cell reaction is zinc metal plus copper 2 ion gives zinc 2 ion plus copper metal. The standard electrode potentials are zinc 2 ion slash zinc metal equal to minus 0.76 volts and copper 2 ion slash copper metal equal to plus 0.34 volts. The EMF of the cell is what? A. Minus 1.10 volts. B. Plus 1.10 volts. C. Minus 0.42 volts. D. Plus 0.24 volts. What's the answer? This question is the cheapest question among these Jamb must repeat questions. Drop the answer in the comment section. No time, no time. Question 130. Which of the following is not a method of preventing corrosion of iron? A. Cathode protection. B. Electroplating with zinc. C. Painting. D. Heating the iron. What's the answer? Drop the answer in the comment section. No time, no time. With all I have here, I can force you to pass Jamb UTME. I can force you to score 280 plus in Jamb UTME. This material you are seeing here is the short material that covers Jamb syllabus for chemistry. I have it for chemistry, I have it for physics, I have it for biology, I have it for English. This file is very short and straight to the point. Straight to the point, what Jamb wants in the syllabus. Why not get this file and disgrace your village people and score 280 in 2 months' time? Why wasting time? Throw away all your textbook. This is what you need. So send me a DM, phone number in my bio if you want this file. Come with your 1K. Do not allow your village people to succeed. Do not allow your village people to use your head to be playing tambourine. Enter DM. Let me redesign your approach to Jamb UTME. Jamb to 826 candidates. Peace out.